afternoon, professors, teachers, and fellow students. Welcome to our presentation. We are from Tang, Shiu Victoria Government Secondary School. And here's my partner, Sheng Pan. And my name is Chang Ken Pong. And our supervisor teacher is Mr. Long. And our registration number is 51088. And our research topic is a theory of blocking geometry from the viewpoint of light and shadow. And here the content shows the order of our presentation. As all of you know, everything on Earth is accompanied by a shadow. And when there's light, there's shadow. But here comes the question. Have you ever deeply think of the relation between you and your shadow? Now, let us look at a simplified reality in the diagram. Suppose we have a light-blocking object A here. And when light comes in this direction, which forms an angle theta with the horizontal, a shadow S is generated. And we have on the shadow-generating object B. And now, to further simplify the situation, we make a few assumptions. First, we assume that the light rays comes from a single source, and the light rays are parallel straight lines, which are vectors of the form in the following. And now we simplify, the simple questions becomes our main concern. That is, we ask ourselves questions. How can we identify a point from S with a point from A? And now we define the shadow as the two sets, that is the boundary and the interior points. So, from which part of the light-blocking object A do they come from? And in mathematical jargons, we say that how can we construct a correspondence between the shadow S and the object A? And to solve these problems, we use affine transformations. This is because the straight line segments can be preserved under affine transformation. And to understand the shadow S, we divide all the cases into three situations: one-dimensional, two-dimensional, and three-dimensional cases. For one-dimensional cases, we apply simple trigonometry and sign formulas to handle these questions. And here shows the object A1, A2, which is perpendicular to the shadow S1 and S2. And for the second case, the object makes an angle alpha with the horizontal level. And here, for obtuse angle, we divide it into two cases. The first one is when alpha plus theta is greater than 180 degrees. And the second case is when alpha plus theta is smaller than 180 degrees. And we come to some retrospections from one-dimensional cases. The line segment is the building block of higher dimensions. And the relationship between two line segments suggests an affine transformation. And now for two-dimensional cases, we apply affine transformation of matrices. And we suggest 6 different affine transformations to deal with different cases. And now let's take a look at the six different cases. For different cases, we use different transformations. And you may take a look at it. And here, case 4 and case 5 and case 6. Okay, now, let's go back to three-dimensional cases. For three-dimensional cases, we discovered something unexpected. That is, the domain of the affine transformation is not always the whole object. The domain equals to A only holds for one-dimensional and two-dimensional cases. However, for three-dimensional cases, we cannot say that the domain is equal to A. Now, let us demonstrate you with the model here. we are going to demonstrate the relations between the sphere here and the 4 parallel straight light rays here. And now we cut it into small pieces of cross sections. Now I will demonstrate the relations between the cross section C and the line segment L and the points of contact P1 and P2 here. And actually, when light goes in this direction, it makes an angle theta with the xy plane here. And the points T2 bracket P1 and T2 bracket P2 here represents the points, the boundary points of the shadow. And from our theory, for any point of the interior point, say T2 bracket K, we can trace back to the object and find a corresponding point K here. And actually, let's apply this situation to daily life. Consider I'm standing here with my shadow here. I can say that one of the interior points of the shadow actually comes from one of the inner points of my body, which may be my organ. Interesting, isn't it? And our findings are significant in that we can identify the boundary and the interior points of the shadow with respect to the object A. And here, we come to the final page, that is the conclusion. Before the conclusion, do you still remember the question for you and me? That is, how can we identify the shadow S from the object A? And here, the following equations summarizes the solutions. And actually, that's not the end of the story. We have suggested some directions for further study. First, how can we determine the shape of the shadow if the shadow generating object B is a curved or irregular surface? And second, what happens if the shadows are overlapped? That is, how can we determine the direction of the light and the shape of the objects? And the last direction of further study is, what are the relations and the differences between shadow and the shade? And so that's all I would like to share with all of you. Thank you.